Hello everyone. Today I'll be presenting about application of graph theory in social network analysis. This presentation explains how mathematical graph concepts are applied in modern social networking platform to power intelligent systems like friend recommendations. So here are the agendas. In today's presentation, I'll be introducing the concept of social graphs. Then I'll explain the core concept of social network graph, including vertices and edges. After that, we'll be exploring real-world application, the friend recommendation system. Finally, we will look at a case study and then conclude with the key takeaways. So we are on to introduction. Graph theory is basically a branch of mathematics used to represent a relationship between entities. In social media platforms, users and their interactions from large networks can be modeled as graphs. Platforms like Facebook, Instagram, LinkedIn, and Twitter are essentially massive graph structures containing millions or billions of users. Graph theory is important because it helps power key features like interaction tracking, target advertising, and especially friend recommendations. So here are the core concepts. A social network consists of basically two fundamental concepts. That is, first we will be discussing about vertices, which represents the users or accounts. Second, it would be edges, which would represent relationship between users. There are mainly two types of graph connections, undirected as well as directed. Undirected graphs represents connections which are mutual, such as Facebook friendships. Direct graphs represents the one-way connection, such as Instagram followers. The distinction is important when designing the recommendation algorithms. Next, we'll be moving on to understanding the graph representation. Two users are considered connecting when an edge exists between them. Mutual friends are users who share common neighbor vertices. Another important concept is the degree of vertex, which refers to the number of connection a user has. The users with high degree values are often influencers or highly connected individuals. By analyzing these graph structures, the platform can predict new possible connections with high accuracy. So let's move on to the next slide. Real world applications. One of the most practical application of graph theory in social network is the people you may know feature. The system uses traversal algorithm to analyze the network structure. It scans for users who share high number of mutual friends based on the structural similarity. It predicts potential connection and also displays them as suggestions. This feature significantly increases user interaction as well as network expansion. So how this algorithm works. So here's a step-by-step procedure. First, each user is represented as a vertex. Second, friendships are connected as edges. Third, the system calculates the intersection of the friend list between users who are not yet connected. Then fourth, users are ranked according to the number of shared mutual friends. Finally, the top rank users are known as recommendations. This process demonstrates how simple graph concepts can produce powerful predictive system. Next, we'll be talking about the conclusion. Let us consider Facebook as a case study. Facebook maintains a social graph containing billions of nodes. It analyzes the neighbors of neighbors to find the strongest connection candidates. This approach benefits the platform in several ways. It helps the users to reconnect with known contacts. It also helps in increasing the daily engagement, also improving the user's attention and network growth. Thus, we could conclude that graph theory directly contributes to the business growth. Next, to conclude, social networks are fundamentally mathematical graph structures. Users are vertices, relationship are edges. By analyzing patterns such as mutual friends and vertex degree, platforms can intelligently predict new connections. This proves that the complex mathematical theories like graph theory are deeply integrated into our everyday life experience. So I'll be concluding with this. Thank you.